Good afternoon, student. This is SP Smart Learning Program. The subject is chemistry, and we are taking the chapter chemical reaction and equation. What is a chemical reaction? The transformation of a chemical substance into another chemical substance is called as the chemical reaction. For example, in our day-to-day life, what we have is rusting of iron, setting of milk into curd, digestion of food, respiration are some of the examples of chemical reaction. The two most important definition what we use in a chemical reaction is the reactant and the product. What is a reactant? The substance which take part in a chemical reaction is called as reactant, and the new substance produced as a result of chemical reaction is called as product. For example, let us take an example. When magnesium reacts with oxygen, what we get is magnesium oxide. So here the magnesium and oxygen are the reactants and magnesium oxide is the product. The second is, what is a chemical equation? The representation of a chemical reaction using symbols and formulae of a substance is called as chemical equation. For example, let us take when A plus B reacts and what we get is C plus D. Here A and B are the reactants and C plus D, what we get is the product. And the arrow shows the direction of the chemical reaction. So the chemical reaction can be written in two forms, that is in word equation and in symbol equation. What is a word equation? When we simply write the names of the reactant and the product is called as word equation, and in symbol equation we uses symbol. Okay, for example, for the symbol equation, when hydrogen reacts with oxygen, what we get is water. What we get is water. So here we use a symbol. So it is a symbol equation. And what are the rules for writing the chemical equation is, the reactants are written on the left hand side with a plus sign between them. The product is written on the right hand side with a plus sign between them. And a arrow separates the reactant and the product. Okay. For example, when magnesium reacts with oxygen, what we get is magnesium oxide. Okay. Here, magnesium and oxygen are the reactants and magnesium oxide is the product. And the arrow separates the reactant and the product. Also, the arrow gives the direction of the product where the product has been formed. Next is, what are the characteristics of the chemical reaction? The first characteristics is generally a change in a color of the reacting species taking part in the reaction. For example, when our iron reacts with oxygen and water, what we get is rust. The iron is gray in color and the rust is brown in color. So there is a change in a color from gray to brown, which indicates that there has a chemical reaction has been taken place. Second is the physical state of the substance normally changes. For example, when magnesium is burned in the presence of oxygen, what we get is magnesium oxide. Here the magnesium is a metal and magnesium oxide, the product, is formed which is white in color. So there is a change in the physical state. As you can see in the figure, when the magnesium ribbon are burned with the with the presence of oxygen, what we get is magnesium oxide, which is white in color and is in powder form. The third indicator, which tells the chemical reaction has taken place, is the evolution of gas. A gas may be evolved. For example, when zinc granules react with HCl, what we get is zinc chloride, and there is the evolution of hydrogen gas. So this is also an indicator which tells the chemical reaction has taken place. The fourth indicator which tells the chemical reaction has taken place is the formation of precipitate. Okay, precipitate is a solid which is insoluble in the solution. For example, when we reacted potassium nitrate, potassium nitrate is the product. Okay, when lead nitrate reacted with potassium iodide, what we get is yellow precipitate settled at the bottom, and this is due to the lead iodide, the formation of lead iodide. So the reactants involved in the reaction are lead nitrate and potassium iodide, which is colorless. When we react the lead nitrate with potassium iodide, what we get is yellow precipitate settled at the bottom, which is potassium iodide, and there is a formation of potassium nitrate as well. Fifth indicator is it is nearly impossible to reverse the chemical reaction. Okay. The sixth indicator, which is very important, is there is a change in the temperature. Okay. When the temperature increases, it is called as exothermic reaction, and when the temperature decreases, what we get is endothermic reaction. So the example for the exothermic reaction is when zinc granules react with H2SO4, there is a formation of zinc sulfate and there is an evolution of hydrogen gas. Evolution of hydrogen gas, as you can see in the figure, okay, and the heat is evolved. So it is an exothermic reaction. And the second is the endothermic reaction. When nitrogen reacts with oxygen, it absorbs heat from the atmosphere, and what we get is nitrogen oxide as a product. So there is a decrease in temperature when this reaction takes place.